Hey class, welcome to Chapter 8 review for your geometry test. Alright, so in this video I'm hoping to go over the majority of the things you need to know. Okay, so starting with Lesson 8.1. Lesson 8.1 was all about geometric means. So just remember, geometric mean is the square root of a times c. So an example, if I asked you what is the geometric mean between 9 and 13, you do square root of 9 times square root of 13. And if you simplify that, the square root of 9 is 3, so you can pull out a 3 in front of your square root and say 3 square root of 13. Okay? The other thing that was covered in Lesson 8.1 was altitudes and how to solve for different sides. So if you look at letter E, which is our altitude here, the way you solve for the altitude is you take the square root of your two numbers on the side that's kind of divided up by that altitude. So square root of 6 times 24 in this case, so that ends up being square root of 144, which simplifies to 12. Okay, what about to find that shorter side length? If I want to find that, I say the square root of the short measure of that side times the whole side length. Okay, so 6 plus 24. So that ends up being 6 times 30, and we take the square root of that, and if we do that, we get approximately 13.4. Sometimes I will say simplified radical, sometimes I'll say round to the nearest 10, okay? Just make sure you read directions. And if I ask you finally to find the longer side, what you do, you take the bigger number times the whole length, okay? So basically same thing, but other side length. And that is everything for Lesson 8.1. Lesson 8.2 is all about the Pythagorean theorem and its converse. So let's just quickly recap. Remember, the Pythagorean theorem is simply that a squared plus b squared equals c squared. You guys have that down pretty well. But let's talk about its converse. Remember, its converse is if you have those side lengths, you should be able to tell me what type of triangle you're dealing with. So if they end up being equal, that's when we have a right triangle. If the two sides added together, or squared and added together, is bigger than your third side, that is when you have an acute triangle. If your a squared plus b squared is less than your c squared, that is when you have an obtuse triangle. So make sure you know that and you're able to identify what type of triangle you have. Okay? Lesson 8.3 is all about special right triangles. So this is where we talked about our 45, 45, 90 triangles. Remember, 45, 45, 90 triangles are isosceles. Okay? So if you have one of the side lengths, you can solve for the other. And the equation to solve for whether it's the hypotenuse or the leg, you take the hypotenuse equals the leg times the square root of 2. If you get confused on which triangle has square root of 2, one way I remember is 2 represents we have two different numbers because we have 45 repeated ones and a 90. So we have two different angle measures in this triangle. That's how I remember that 45, 45, 90 is the square root of 2. Okay? As far as the 30, 60, 90 triangles go, the shortest side is represented simply by the variable s, or whatever variable it says on the test. The hypotenuse is twice the shorter side, and the leg is the shorter side times the square root of 3. Again, I get that because I have 3 different angles. I have a 30, a 60, and a 90. Okay? Make sure you have those formulas memorized. Lesson 8.4 is all about trigonometry. A lot of you have this down pretty well because of the lovely SOHCAHTOA song. So remember, sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you want an angle, this is the place where a lot of you get confused. You're going to use the inverse operation. So if I want to find an angle and I have the opposite side and the hypotenuse, I'm going to type into my calculator sine inverse, which is your second key and then the sine key. And then I'm going to type in whatever the length of my opposite is divided by whatever the length of my hypotenuse is. Same thing goes for cosine and tangent, okay? Just depending on what angle you're looking for and what sides you have. So just remember, if you are looking for a side, you use regular SOHCAHTOA. If you're looking for an angle, you use the inverse operation. Lesson 8.5 was all about the angles of elevation and depression. So I drew a quick picture here to help you remember what an angle of elevation and angle of depression look like. So remember, if we have the black line represents our line of sight of whatever it is we're looking at, below that line of sight with an invisible horizontal line, or sometimes there is a horizontal line, that is called your angle of elevation. And anything above your line of sight with that invisible horizontal line, or sometimes there is a horizontal line, that is your angle of depression, okay? Lesson 8.6 is all about our law of sines and law of cosines. So law of sines is used when you have angle, angle, side, angle, or side, side, angle. And remember, that's just ratios. So sine of A over A equals sine of B over B equals sine of C over C. Okay? As far as law of cosines you use it when you have side, angle, side, or side, side, side. And something to help you remember is C squared equals A squared plus B squared. That first part of that formula is the Pythagorean theorem. Okay? So hopefully that'll help you remember, because some of you get overwhelmed by how long this formula is. And then the second half is just the little extra bit to remember. It's negative 2 times AB times cosine of C. Okay, so make sure you remember how to plug numbers into that problem, those types of problems. Now, lesson 8.7 was all about vectors, and vectors, remember, are all about the direction and magnitude. The standard position is when the tail of the vector is located at 0, 0. That won't happen all of the time, but just remember that's your standard position. Then our component form is when you have kind of the pointy brackets like this, okay? Except you only have one set of them. Right now there's two because I just drew next to it. And it's x2 minus x1, comma, y2 minus y1. Some of you got to those problems in the book and you said, this can't be right, it was too easy in comparison to the rest of it. But no, really, it is that easy. So don't overthink that. And then the magnitude, you just use your distance formula. You guys are very good about that. Let's talk about our direction. This is where things tend to get a little more confusing for vectors. So our direction is first try to make a right triangle using the tip to tail method. So as you can see in the drawing, I took the tip of this one and I took the tip of the green arrow and put it to the tail of the blue arrow. Okay? And then the answer is the red arrow that connects the two. Okay, and then what you do after that is you take tangent of theta, so that's whatever that angle measure is, and you take the absolute value of the y2 minus y1 over x2 minus x1, and then you have theta equals inverse tangent of that fraction. This right here, I don't remember if I mentioned it, this is pronounced theta. It's just another variable. You'll see it used more and more frequently as you progress in mathematics to represent angles, okay? Instead of using x, you start using theta, okay? It's just another Greek letter for you. Once you have that, you are pretty much set to go. You just have to, if we're talking about something in a coordinate plane, if we are down here for our angle. Remember, you need to add 90 for this coordinate, or for this quadrant. You add 90 more, and then whatever theta is. So if theta was 45, you would add that 45. So your answer would be 180 plus 45. So you'd tell me that that answer is 225 degrees, okay? So make sure you just remember to add however many degrees are necessary based on what quadrant it is in, right? If you have any questions about those, please be sure to reach out for some help before your test. You're always welcome to come in before school or email me. I hope you guys have a good day.